Mathers, and welcome to our first Saxon math lesson together. Today we're going to be learning about adding whole numbers and money, subtracting whole numbers and money, and some fact families. So first we have some key vocab. Addends are any numbers that we're adding together, and the answer is the sum. If we change the order of the addend, it does not matter. We already learned this. It's the commutative property of addition. So 3 plus 5 equals 5 plus 3. When we're adding two addends, we want to make sure that we line them up on the right hand side right here. So 345 plus 67, we would line up the 5 and the 7, and then we would add straight down starting from this side. If we have a tens and we need to carry it, we'll write the ones there and we'll carry the tens up here. We add right down, and the answer is our sum. We can always check our answers too by going backwards and adding the okay, changing the order of the addends doesn't matter. If we added 67 plus 345, it would be the same thing. So here is your first vocab stuff you need to put in your notebook. Addends are the numbers being added, and the sum is the answer of the addition problem. 5, in this case, we have 5 plus 3. So the 5 and the 3 would be the addends, and the 8 would be the sum. What about with subtraction? Okay, with subtraction, we subtract one number from another to find the difference. In a subtraction problem, the subtrahend is taken from the minuend. So the first one is the minuend. The minions come first, and the subtrahend comes second. That's what's being subtracted, and then that is called the difference, the answer. Okay? Now, the commutative property does not apply to subtraction. It's only for addition. And later on, you'll learn how to make subtraction problems into addition problems so you can switch them around. But you can't switch 345 minus 67 is not the same thing as 67 minus 345. When we're solving the problems, you do the same thing with addition though. You want to line them up on this side. You just can't switch the order. The subtrahend should be on the bottom of the minuend, and then your answer is the difference. Okay, so here's some more vocab. The minuend is the big number, or the number that you are subtracting from. The subtrahend is often a smaller number. It's what's being subtracted, and the difference is the answer. So in this example, 10 would be the minuend, 2 would be the subtrahend, and 8 would be the difference. Sometimes you'll have to borrow in order to subtract down. Pretty sure you already learned all of that. Okay, we can check a subtraction problem by adding. So you subtract down to find the difference, and then you can add up 375 plus 125 equals 5 to make sure that it's right. Here's some more vocab for us. Addition and subtraction are called inverse operations. We can undo an addition by subtracting one addend from the sum. The three numbers that form an addition family also form a subtraction family. Here we go. 4 plus 5 equals 9. 9 minus 5 equals 4. So the numbers 9, 5, and 4 are all a part of a fact family. We can arrange them in lots of different ways, and they will work out just great. The commutative property does not apply to subtraction, so we can't reverse the first two numbers of a subtraction problem, but we can reverse the last two numbers. So for example, 11 minus 6 equals 5 also works as 11 minus 5 equals 6. For the two addition facts, 11 is the sum. So working backwards, 5 plus 6 is 11, 6 plus 5 is 11, and that's what it's telling us right there. And our last vocab word is inverse operations. Inverse operations undo each other. So just like 3 plus 2 equals 5, 5 minus 2 equals 3. So addition and subtraction are called inverse operations. A little hint for the future, multiplication and division are also called inverse operations. All right, now you're ready.